Welcome to Building Data Streaming Platform with Kafka. This is your host, Sam Shah. This will be a hands-on technical video. Some Apache Kafka basic knowledge will be very useful. Special thanks to Sandeep Bishnoi for his deep technical expertise and Sanjay Goyal for making this video possible. What is Kafka and what can it do? Kafka is an open source, publish and subscribe messaging system. It is based on distributed commit log. Kafka's reliable delivery makes it perfect source data for stream processing systems. Oracle Event Hub is built on open source Confluent platform. When you provision Oracle Event Hub dedicated service on Oracle Cloud, it creates everything you need. It creates VMs for Kafka brokers, Zookeeper, REST proxy, the registries, and so forth. It also makes it easy and simple to move data to and from Kafka using connectors. Let's look at some of the use cases for Event Hub. There are several use cases for Event Hub. Let's focus on one of them, the IoT use case. In IoT use case, you can have any different types of devices. You can have a heart rate monitor, a pacemaker, a blood pressure machine. You can have any one of those devices which can produce messages or data which can then be categorized and placed in different topics within Kafka. Once you have these messages in Kafka topics, you're able to do stream processing using systems such as Apache Storm, Spark Streaming, Flink, and so on, as well as stream analytics using Oracle Stream Analytics or OSA. You can also move the data from Kafka to different destinations, such as Oracle Object Storage or Oracle Autonomous Data Warehouse. In this video, first we will provision the Oracle Event Hub dedicated service. Once we have that up and running, we will quickly test publisher and subscriber with Apache Kafka client. Then we will use the REST API. For the REST API, we will use a tool called Postman. Finally, we will test some Kafka connectors, namely Oracle Cloud Storage and JDBC connector. For JDBC connector, we will use Oracle Autonomous Data Warehouse Cloud as destination. For this, we will leverage Python producer and consumer. So overall, in this video, you're going to see three different types of producers and consumers, as well as two types of different sinks. The source code is available on GitHub. Let's start with step one. Once you have an Oracle account and you have successfully logged into Oracle Cloud, you will come up to a dashboard like this. Once you're at the dashboard, on the upper left-hand corner, you will see a menu. Click on that menu. You will see a list of all the services there. From the list, select Event Hub Dedicated. Here, you can create a new instance of Oracle Event Hub Cloud Service, or the Kafka cluster. Let's go ahead and click on Create Instance. I want to capture data from pacemaker devices. So I'm going to name my instance Pulse Stream. The idea is once you capture this data through Event Hub, you probably want to do a lot of stream analytics on top of it. Next, you can go ahead and select the region. I'm going to go ahead and select US Ashburn 1 as my region. Next, I can select my availability domain. Here, you have ability to select multiple domains. If you want high availability, then you can select multiple domains. In my case, I'm going to just select one domain. Next, you need to select the subnet. You can leave it as no preference, or if you have a compartment with a VCN and a subnet in it, you can also go ahead and select that. In my case, I have a compartment named demo. I have a VCN named demo VCN, and here's the subnet name itself. So I'm going to go ahead and select that. Next, I need to select the software release. Here, I'm going to have Kafka latest release, which one is 1.1. So let's go ahead and select that and click on Next. For deployment type, there are two types. One is called Basic and the other one is called Recommended. Basic basically means you're running your Kafka broker and Zookeeper on the same node. Recommended basically means you're running your Kafka broker and Zookeeper on separate nodes. You can click on the question mark next to it to get better explanation. Next, I want to select the SSH public key here. If you want to SSH into those nodes, then you can specify the keys right here. So I'm going to click on Edit. I have pre-created a key for me, so I'm going to go and use that key. Here's my key. I'm going to select that and click on Enter. Now that I have my SSH public keys, I'm going to select the number of nodes for Kafka. Here you can specify multiple nodes, or you can simply select one node and scale later. I'm going to go ahead with one node here. For the compute shape of that node, I'm going to select the shape of 2 OCPUs with 30 GB RAM. So I'm going to go ahead and select that. You can also change the storage. You can also make the network type either public or private. You can specify credential. These credentials are for user authentication for topic URL. If you wanted to do that, you can go ahead and specify the password here. Next, for REST proxy, you can also specify number of nodes in the shape. I'm just going to go ahead with the default. You can change it if you feel you need more nodes or bigger shapes. Finally, Kafka Connect. If you want to create a file sync or object sync from Kafka, you can go ahead and select the Kafka Connect checkbox. Once again, here you specify the number of nodes and the shape of those nodes for Kafka Connect. Once you have specified all these parameters, you can go ahead and click on the next button. On the next screen, it's going to summarize all the data that you have entered here. And once you review that, you can go ahead and create the cluster. So here's the data I have entered. I'm just going to go ahead and create the cluster. Once this is created, we will look at the VM it has created for broker and Zookeeper, as well as REST proxy and the Kafka Connect. You should be able to note down the IP addresses for those boxes, and we will move forward with the next step. Once the Oracle Event Hub Cloud Service is provisioned, click on the name to get more detail. As you can see, there are 3 nodes created. The first node is your Kafka broker and zookeeper. Remember, we specified basic deployment, so both of these are running on the same box. You can also note down the IP address and the port number. In some cases, port will need to be opened depending on your cloud configuration and security and network configuration. The second VM is the Kafka Connect VM. We will be using this for our object sync. And third one is the REST proxy API. We will use this VM later on to post some messages to our topic using REST API. It is important to note that the topic name by default would be the same as the name of the instance you provisioned. So when we provisioned this instance, it created a topic with the same name. What we want to do next is SSH into our broker box. If you notice, I'm using the same IP address as you see over here. You can log in as the user OPC. Once you're logged in, I'm going to change user to Oracle. Now, if you notice, I have 2 SSH windows here. The reason for that is the top one, I want it to act as a producer, and the bottom one, I want it to act as consumer. So we can post messages on the top, which should right away show up on the bottom window, in consumer window. We can also use shell scripts that come with Confluent Kafka client. Using those shell scripts, we can easily produce messages and consume messages. So first, let's go to that directory where the client is installed. Here you can see all the scripts. I have also similarly logged in to the bottom window to the same VM with same credential, and I am in the same directory. First, what I want to do is look at the details for our topic that the service created. So I'm going to go ahead and put the command here. There's a shell script called Kafka topics, which is connecting to our zookeeper on port 2181, and it will be describing our topic, which has the same name as our instance, which is Pulse Stream. You can very easily create more topics either by using Event Hub, or you can use one of the scripts from the same Kafka client to create another topic. So let's go ahead and look at some details of our topic. As you can see, the replication factor is 1. There are 2 partitions, partition 0 and partition 1. Next, in the bottom window, I want to go ahead and run the consumer program. So there's a script called Kafka console consumer, which you can use to start consuming from a specific topic. So let's go ahead and put that in here. So here's the script name, Kafka console consumer. Again, it's connecting to same bootstrap server on port 667, and it will be consuming messages for our topic Pulse Stream. So let's go ahead and enter. Now if you notice, I have a option here that says from beginning, and as you say, it's gonna show you all the topics that we already have in the queue, which you see up here. Next, what I want to do on the top window is start our producer. So this is our producer. So I'm running a script called Kafka console producer. Again, it's connecting to the same broker, and it will be posting messages for our topic pulse stream. Now that you see the prompt there, you can start putting the messages. I'm gonna go ahead and put my pulse there. Let's say it's 90. As soon as you put the message there, it shows up at the bottom. So this is the publisher, this is the consumer. Let's put another message. Pulse are 95. So this is a quick way, once you have the Event Hub instance created, using the Kafka client, Confluent Kafka client, you can easily start testing producer and consumer. To work with REST API, we will use Postman. Once you have Postman installed and up and running, go to Settings and turn off SSL certification verification if you're not using certificates. Next, make sure you have the IP address of the REST API VM and user ID and password that you specified during the Event Hub dedicated service provisioning process. Alternatively, you can also use authentication with Oracle IDCS. If you want to do that, then use OAuthentication 2.0. Now that we have the basic setup done, let's go ahead and create some producers and consumers using REST API. Let's start with a request that will get you all the topics that you have. To do that, first change the request type to GET, and then specify the IP address of the REST API server along with the port number, which in our case is 1080 /REST proxy /topics. This will give you the list of topics that we have. Now, if you notice, I also specified the username and password here. This will be required for you to get the list of topics. Here, there are other authentication mechanisms that you can leverage as well. So let's go ahead and send this request over. Here's the response. In response, you can see that we have two topics. One is called Pulse Stream and the other one is called Pulse Stream A. Now, we may want to get more details about this specific topic. So let's go ahead and build that URL request. Again, this will be a GET request. Same IP address and the port number, everything will be the same, except this time we're going to append it with a name of the topic for which we want to get details. Nothing else has changed, so we can go ahead and click on the send again. This gives you a lot of details about the topic itself. If you notice, it also tells you how many partitions are used. In this case, it's using two partitions, one partition 0, the second one is called partition 1. You can also see replicas and so forth. Now that we have more information about this specific topic, how about posting some messages to it? You can do that by creating a post request. So this time, instead of get, we have post. Everything else remains the same. So this basically means we're going to post messages to our topic called Pulse Stream A. There are two additional steps required to post messages. The first one is within the header, you need to go and specify the content type. For content type or for the media types, you can look up the documentation. These are the supported media types that Event Hub currently supports. I selected this one, which is a form of a JSON. And then the second thing is within the body, you need to actually specify your messages or the data. So in my case, I'm sending two messages. One has a value, Jane Doe, she has pulse of 91, and also John Doe, who has pulse of 101. So let's go ahead and change these values to something else. So I'm going to say this is 80 and John's pulses are at 70. So these are the two messages that we will be posting to our topic called Pulse Stream A. So let's go ahead and simply click on the send button. And here's the response. With the response, you can also see the offsets or any errors if there were any. In our case, you can see there's an offset 5 on partition 1, and also on partition 0, the offset is 5. Now, if I were to post more messages, then these offsets will basically go up. So let's go ahead and put a couple of more messages and see what happens to the offsets. So I'm going to make this 81, and I'm just going to make this 71 and send the request again. And as suspected, the offsets now went up to 6. So we have successfully posted more messages to our topic. How about we now go consume these messages? To consume messages, first create a consumer group. So as you can see, I have specified now a consumer group here. And then I also changed the body. To create that consumer and consumer group, you can specify the name of your consumer along with other data values. Here, I'm just going to create a new consumer, and I'm just going to call it consumer 6. And I'm going to send the request over. It has now created a consumer instance ID called consumer 6. And it's also giving you a base URL. We will be using this base URL for next 2 steps. So make sure you go and copy this. So I'm going to go ahead and copy this URL. Once you have done this, you need to subscribe to the topic. So now we have our consumer group, and we have a consumer instance called consumer 6. This consumer 6 now needs to subscribe to a topic. So that's what we're going to do in the next step. In the next step, on the address bar here for the post request, you should go ahead and paste what you copied in the last step, which was this URL right here. So I have done that same thing here. However, I'm going to go ahead and change my consumer from consumer 5 to newly created consumer number 6, and then say subscription. Here, you're basically subscribing, so you need to pass some data indicating what topics you are subscribing to. In my case, in the body, this is how I specified that I want to subscribe to Pulse Stream. Again, another JSON document. And with this, we can go ahead and send the request over. So we have subscribed to consumer 6 has now subscribed to Pulse Stream A. Final step is we want to go ahead and consume the data. So to consume the data, create a GET request. Here, paste the same URL that you copied earlier. I have done that already, but I just need to change from consumer 5 to consumer 6. You may not need to do that. And of course, this time Instead of subscription, we're going to say records. So this basically is going to return all the records that we have in that topic. There's no other change you need to make except that instead of content type, this time I have specified the accept type. So for the accept, make sure this value is the same as what you specified earlier during producing the messages. They need to match. Now let's go ahead and send the request over. And here are all the messages for our topic. Let's go ahead and allocate the ones we recently posted. Here they are for pulse stream A. John Doe, who has a pulse of 70. Jane Doe has pulse of 81, and so forth. And you can also see the offset. So if you remember, the offset was 6. You can see the messages that you have for the topic. So it's a pretty straightforward to use REST API with the Event Hub dedicated service. It's very easy to create producers and consumers and start doing your publisher and subscriber type of applications. As you recall, when we provisioned Event Hub dedicated service, we had specified Kafka Connect. Using this Kafka Connect, we can now configure Kafka Sync. There are many types of Kafka syncs. One of them is the object storage sync. We will talk about the other types of sync briefly on the next slide. When setting up the object storage sync, make sure you have access to the Oracle Object Storage and you are able to create buckets in it. You also need to capture the tenancy and user OCIDs. If you're not sure how to do that, there's a link at the bottom. You can use that to get your tenancy and user IDs. You will also need to generate the API signing key. The same link shows you how to do that. In case of Oracle Autonomous Data Warehouse Cloud Sync, you will need to configure your JDBC connector. There's a link at the bottom that shows you how to do that as well. Sync connectors help you extend your data pipeline. It lets you copy the data or messages from Kafka topics to other destinations such as Oracle Database, MySQL Database, Oracle Autonomous Data Warehouse, as well as Oracle Cloud Storage. The other connectors include Web Services Sync Connector and File Sync Connector. Here are the high-level steps when you are creating the Oracle Cloud Infrastructure Object Storage Sync. First, make sure you have completed all the prerequisites. Then, upload the public API signing key to Oracle Cloud Infrastructure. You can copy the private API signing key to Kafka Connect VM in the directory shown below. We will then create the Kafka sync from Event Hub Cloud Service Console. Here you will need to specify the tenancy OCID, the user OCIDs, the location of your PAM file, and so forth. Most of these that you captured during the prerequisites. Finally, we will post some messages to our topic to test the Kafka sync. Let's quickly check our prerequisites. I'm going to go back to the menu. Look at the object storage. In the object storage, as you can see, I am able to create a bucket. I created a bucket called Kafka Sync. We will use this Kafka Sync bucket to put all these messages from our Kafka cluster topic. Next, I want to quickly check my API signing key, click on the username, and as you can see, I have uploaded an API key here as well. So that looks good. On the Kafka Connect box, as you can see, here's my original provisioning with the Kafka Connect VM. I'm going to look at the current directory and quickly see what I have in there. I already loaded a PAM key here as well. So at this point, I have uploaded the private key in my Oracle Cloud infrastructure under my user, and I have also uploaded the private PAM key to the Kafka Connect VM. Next, if I take a look at the Event Hub Cloud service, if I go ahead and click on the menu here and go to Event Hub Cloud Console, which will bring me to a screen like this. Here you see a nice summary of how many brokers I have, my broker IP, and it is up and running. The throughput, the messages in, messages out, produce requests, the fetch requests, all those nice statistics and numbers can be found here. Also, you can see how many topics I have. I have 2 topics created. Connectors, I already have 2 connectors created. One is called Pulse Sync, which is the Oracle Cloud Storage sync connector, and the other one is a autonomous data warehouse connector using JDBC. So I have 2 connectors already created. In settings, you can also see the credentials stored. So with this, we are ready to go ahead and create a new connector. Keep it in mind, you can use this user interface to create a new connector, or you can use your REST API to do the same thing. Here, let's quickly create a connector. In this case, we're not creating a source connector, but we are creating a sync connector, so we will go ahead and select that. Click on Next. Select the topic. Let's select the Pulse Stream A topic. And here are the different sync connectors. I'm going to go ahead and select Oracle Cloud Storage. Click on Next. So here's your source and here's your sync connector. Clicking on Next, we can fill in the parameters here. The connector name, let's call it Test Sync. All right, I'm just going to take all the defaults. For the key and value converter classes, you have a choice whether you want to use byte class or Avro. You have those choices. For the flush size, just for the demo purposes, I'm going to set it very low so that we can see the messages written to object storage right away. So I'm just going to select 1. So even if one message is put on Kafka cluster topic, I should be able to see that in my object storage. It's going to commit right away. The other things, the main parts are here. So here's the OCI Cloud Storage URL. This is based on the earlier slides where we discuss the sample parameters, configuration parameters. You can basically input similar parameters here based on your values. So I'm going to go ahead and put the URL of the object storage. It is in US Ashburn 1, so I'm going to put that in. Here's my bucket URL. Next. And here's my bucket URL. As you can see, this is the bucket that I'm going to use. And this is my tenancy. I'm using any other directory structure underneath. Otherwise, you can specify it over there as well. My tenant OCID, which I have captured from my prerequisites. So I'm going to go ahead and paste that. Here's my tenant OCID. Then you need user OCID. Again, as part of our prerequisites, we have captured that. PEM file path. So this would be the PEM file that you copied on the Kafka VM. So you need the path of this directory, which is this, that you can copy and paste just the path on Kafka VM. So I'm going to go ahead and paste that. So here's the full path. And finally, my PAM key fingerprint. You can get that fingerprint from your user information that you saw on identity user screen before. And click on your username, and you can see the fingerprint over there as well. But here you have a couple of options to either do a direct entry, or you can specify the credential store. As you saw earlier in settings, we were able to store it there as well. So I'm going to go ahead with the direct entry approach. I'm not sure what this is, so I'm going to go ahead and copy my fingerprints. Okay, all the other parameters are optional. We're not going to get into that, but one of them I'm going to mention, which is quite interesting, is for partitioner. You can select different partitioners. So for example, you can select time-based partitioner or daily-based partitioner, so you can create different directory structure based on the time and so forth. But for our purpose today, we'll just take all the default parameters there, and let's go ahead and create it. If you're not sure about what the other fields mean, you can simply click on the question mark here, and it will actually explain what those parameters are. Let's go ahead and click on next. It shows you a quick summary. We can review it and click on create. So this will go ahead and create the Oracle Cloud Object Storage Sync for us. So here it is. So we have now 3 connectors. This is the new one we just created. It is running. You can also check the task details. You can restart. If you want to edit the configuration, you can simply click on Edit Configuration there and change the configuration as well. So again, these are all the configuration parameters we had entered earlier. Next thing, what we can do is put some messages in our queue, or sorry, in the topic, and then we can see if messages show up in our object storage. Now that our test sync is up and running, we can go ahead and quickly test it. We can again go back to Postman and use REST API to produce some messages for our topic. So here's the same topic, which is Pulse Stream A. Here are a couple of messages that we will produce for that topic. I would just go ahead and send it. Please note down the offsets. It's the offset 28 on partition 0, and also on partition 1, offset is 28. So let's go back to our bucket and see what is happening there. So I'm going to go ahead and go back to our bucket. Here's our Kafka sync that we configured. Let's go there. I'm going to go all the way at the bottom. Since this is flushed, remember we specify flushed value equals to 1. It's already committed. And here's the offset. You can see offset 28. This is on partition 1. And here's our topic name. So you can basically see the format there. I'm going to go ahead and download this and see what's in it. Let's open it. I can open it with the notepad. and this one has John Test 70. That's the same record we produced for the topic. Now, if you want to see Jane Test 80 record, it's probably in partition 0. So let's go ahead and allocate partition 0 with the same offset 28, which is right here. So if I go ahead and download this, this should probably have Jane. And quickly go ahead and take a look at it in the notepad. Here it is. So our test is successful. We have successfully configured our object storage sync with Kafka Connect. For JDBC connector, make sure you already have Autonomous Data Warehouse or Oracle database provisioned already. Make sure you have access to create tables as well as select data from those tables. You may want to set up a Python environment as well, since in this exercise we will be using Python consumer and producer. There are a couple of helpful links at the bottom. If you want to take this a step further, once you have data in Autonomous Data Warehouse, you can very easily do machine learning on top of it. So there is another video that specifically shows you how to do that. Finally, in this example, we'll be using Confluent Kafka Python. So let's get started. So I'm using PyCharm for Python. You can use any of the tools you like. There's a good reference for the code that I'm using. I have basically modified that code to work in my cloud environment. What you see on the right is the producer code. So I am using the Confluent Kafka Python. What you see is, first of all, the schema. Here's my value schema string. I'm defining patient name, pulse, and pressure, blood pressure in my schema. I have also specified the data types as well as the defaults for those fields. You can optionally also define the key schema, which is shown here as an example. However, I'm not using that in this particular producer. Next thing is some configuration for the producer. Here's the Bootstrap server. Here's my IP address and port it's listening on. You also need to use schema registry. So here's the URL for schema registry. Important to make sure that you have appended schema registry at the end there. And finally, there's a call to produce a message, which is right over here. And you can see this is producing a message for my topic called Pulse Stream Avro PY, PY for Python. You can name it anything you want. And here's the value that I'm passing. This value can be seen right up here. So basically I'm sending patient name, which is Jane Doe, the heart rate, which is about 72, and pressure being 130/80. So this is the message we want to send over. Before we do that, let me go ahead and quickly start the consumer so that we can actually see the output there. So I'm just going to switch to my consumer. It seems it's already running. So let's go ahead and produce the message. Okay, our code has run successfully. Let's go to the consumer window, and you can see that there was a row added, and it is visible on the consumer side. So this is a nice way to have a producer and consumer producing Avro messages and storing it in Kafka and consuming it in another Python program. But what we want to do next is take these Avro messages and put it in the Autonomous Data Warehouse. To do that, we will create a JDBC sync using JDBC connector. To do that now, let me quickly go to the Postman. You can also do this using the graphical interface. For example, here's what my screen looks like. So I can go here and create a new connector just like before. However, I wanted to show you the REST API here, so I'm going to use the Postman just to create the connector. Here's my connector configuration that I'm sending in the body of this URL. Here's the name of my connector, right? We are using the JDBC sync connector as a connector class. Here's my topic, the same topic that you saw just a couple of minutes ago. Here's the table name format. This is the name of the table it will create in Autonomous Data Warehouse. I am not using any primary keys, so you basically see that to be none. Here's my connection URL. This connection URL is for the Autonomous Data Warehouse instance that I have up and running, but this could be any other Oracle databases or any JDBC destinations. Here's my connection user and password. This password is already predefined. So let me quickly show you that. So if you go to the settings here, you can see the password is already set up. So I don't have to type in the actual password here. I have a couple of good options here. I wanted to create the table automatically and evolve, so those parameters are set to true. I also set the batch size to be very low, to be 1. So as soon as we produce the messages, I want those messages to be propagated or moved to Autonomous Data Warehouse as well. And finally, there are two converter classes that we need to specify. Here's the key converter and here's the value converter class being defined. Again, if you do it through the graphical user interface, you don't need to know all these things. It becomes much more easier and simpler. I just wanted to show you actual parameters that basically get specified when you use the graphical user interface. That's the only purpose. So let's go ahead and execute this. So I'm going to go ahead and send this to create our JDBC connector to Autonomous Data Warehouse. And here's the response. It has done that successfully. So great. At this point, we should have a table in our Autonomous Data Warehouse instance. For that, I am using the JDeveloper. So here's my JDeveloper. I have 3 tables there, and we should expect one more table to show up, which is right there. So it created the same table, pulse stream Avro PY. If you notice, that's the table format that we specified to be created. Next thing we can do is look at the table. It created this table with 3 columns, patient name, the pulse, and the blood pressure. And there are the defaults, as you can see. Based on the schema that we specified, it registered, and that's what it used to create the table here. We can also look at the data. There are 2 rows in our table already. So what I want to do is I want to produce another message for our topic and make sure that it shows up over here as row 3. So let's go ahead and do that. I'm going to go back to our Python producer here. I'm going to change the data a little bit here. Let's make this John Doe, who has pulse maybe a little bit higher, 90. Maybe he needs to go see a doctor. This one may be 85. And we can go ahead and run this program as well to produce another message. It is done. Let's go back to our JDeveloper. Let's refresh the data, and it's already there. So this is John Doe, the pulse and the blood pressure and so forth. And again, as I mentioned earlier, we can extend this further to do machine learning once you have the data in autonomous data warehouse. There are lots of tools that you can use. You can use the SQL interface to create your notebooks. You can create Jupyter notebooks as well using Python interface. There is so much that you can do once you have all this data in autonomous data warehouse. Another thing I wanted to quickly show is the registry. So if I go here, I'm going to do this in Postman. I can go ahead and try to see what's being registered in there. So there are about 5 or 6 schema registries I have. This is the one that we have created. I can also kind of see what versions of my schemas exist by just kind of sending this message. So there's a version 3 in there, and in the next line I basically want to get more details. So it shows me here's our subject, which is pulse stream Avro PY. Version 3 is the schema ID, and here's what the schema looks like. So this basically matches up with the table definition that you just saw in the autonomous data warehouse table. In summary, there is a lot that you can do with Event Hub. We saw different use cases, we saw different types of producers and consumers. Now it's the time to take it out for a spin.